So good morning. So this time let's have some more problems regarding direct variation. Okay, let's have the first problem. So the amount of money raised at a charity fundraiser is directly proportional to the number of attendees. The amount of money raised for 5 attendees was $100. How much money will be raised for 60 attendees? So here, we need to create first the equation of our variation. So we have here, so the important words are the amount of money. It's directly proportional to, and of course, the attendees. So if we put them together, we are going to have M is equal to K times A. So that is now our equation. Then we are going to solve for our constant K. So we go back to the problem. So our given there will be, so money will be $100 or M for $100. So A, that is 5 attendees. And of course, we will be solving for the constant K. So we are going to use the equation M is equal to K times A. We substitute our given. So we have there 100 is equal to K and A is equal to 5. And since we are solving for the K, we are going to divide everything by 5. So divide everything by 5. 100 over 5, that is 20. We cancel the 5, so that would leave us K. So our K here, or the constant of variation for number 1, is 20. And we will be using the K in order for us to solve for how much money will be raised for 60 attendees. So our equation once again is M is equal to K times A. So since we are solving for the money, so K is equal to 20, and this time our attendees is 60. So 20 times 60, that would give us $1,200 for 60 attendees. Okay, now let's have for problem number 2. The gas pressure in a chamber varies directly with the temperature in the chamber. If the pressure in the chamber is 150 atmospheres when the chamber is at 50 degrees, what is the pressure in the chamber when the temperature of the chamber is 75 degrees? Again, we are going to create our equation. So we go back to the problem. We have there the pressure varies directly to the temperature. So our equation will be P is equal to K times the time. Now we will be solving for the constant K. So our problem there, we have there the given. So we have there P is equal to 150 atmosphere and the temperature is 50 degrees. And we are solving for our constant K. So again, our problem or our equation will be P is equal to K times time. So we substitute the given. So we have 150 is equal to K and the temperature is 50. So we divide everything by 50. So 150 over 50, that is 3. We cancel the 50, leaving us the K. So our K for number 2 is equal to 3. Now, what is the pressure in the chamber when the temperature of the chamber is 75 degrees? So our equation there is P is equal to K times time. And we are solving for the pressure. Our K is 3. And this time the temperature is 75 degrees. So 3 times 75, that would give us 225 atmospheres. Make sure that you have there the correct unit. Okay, now let's have problem number 3. Trina's paycheck earnings varies directly as the number of hours she works. If she works 19 hours and earns $187.15, what should she earn if she worked 40 hours? Okay, so again, our equation will be, so we have there the earnings varies directly and of course the hours. So our equation will be E is equal to K times H. So solving for the constant K, we go back to the problem we have there. So earnings is $187.15 and the number of hours is 19. And we want to solve for the constant K. So again, our equation will be E is equal to K times H. So we simply substitute. 187.15 is equal to K times 19. So we divide everything by 19. So 187.15 divided by 19, that would give us 197 over 20. We cancel the 19, leaving us the k. So our k here is 197 over 20. Now letter C. What should she earn if she worked for 40 hours? Again, our equation is E is equal to K times H. So we are going to substitute. We are solving for how much she is going to earn. Our K is 197 over 20. And the number of hours this time it's 40. So we multiply. 197 over 20 times 40, that would give us $394 for working for 40 hours. Okay, problem number 4. The number of words Maria typed vary directly with the amount of time she spent typing. If she typed 275 words in 5 minutes, how long would it take her to type 1,100 words? So again, we are going to make first the equation of variation. So we have there the number of words varies directly to the time. So W is equal to K times T. Now, solving for the constant. So our given there, we have 275 words in 5 minutes. So we have W is 275 words and the time is 5 minutes. And we want to solve for the constant K. So again, our equation is W is equal to K times the time. So we substitute. So 275 is equal to K times 5. Dividing everything by 5. So 275 over 5, that would give us 55. We cancel the 5, leaving us the K. So our K here for number 4 is 55. Now, how long would it take her to type the 1,100 words? So we are solving for the time this time. So again, our equation is W is equal to KT. How many words? That is 1,100. Our K is 55. And we are solving for the time. Divide everything by 55. So 1,100 divided by 55, that would give us 20 minutes. Cancel this, leaving us the time. So therefore, it took Maria 20 minutes to type the 1,100 words. Okay, now, problem number 5. The amount of money earned on a job is directly proportional to the number of hours worked. If $70 is earned in 5 hours, how much money is earned in 22 hours of work? Okay, so again, our equation will be, so we have there the money directly proportional to the number of hours. So we have M is equal to K times H. So our given to solve for the constant K, we have $70 in 5 hours. So we have there, so 70 for M and T 5 hours. And we are solving for the K. So using the same equation, we are going to substitute the given. So M is 70 is equal to K and H is 5. Now, we divide everything by 5. 70 over 5, that is 14. We cancel this, leaving us the K. So our K is 14. Now, we are going to solve how much money is earned in 22 hours of work. So the same equation, we are solving for the money. So K is 14 and the number of hours this time is 22. So 14 times 22, that would give us $308 of amount of money in 22 hours of work. Okay, so that's all for today. I hope direct variation is quite clear now. Thank you so much.